signaling. So, time division multiplexing is possible when the bandwidth of the medium exceeds the data rate of digital signals to be transmitted. So, here when the bandwidth of the medium exceeds the data rate of the signals to be transmitted. So, the possibility arises because of the same reason as frequency division multiplexing. However, it is done in a different way. Here what we can do, multiple digital signals can be carried on a single transmission path by interleaving portions of each signal in time. So, we shall interleave different signals one after the other and send through the medium. So, interleaving can be done at the bit level or in the blocks of bytes. It may be possible to do the interleaving at the bit level, say one bit of one signal, second bit another bit of another signal, and third bit of another signal, and so on. It can be done, the interleaving can be done in this way, or interleaving can be done in terms of blocks of bytes. And of course, as we know, here we have to generate data in digital form, and you have to do suitable encoding like digital data to digital signal encoding, or if your data is analog in nature, then you have to convert into digital form by using pulse code modulation or delta modulation, get the digital signal, then you can do time division multiplexing. So, here what we do, the incoming data from each source are briefly buffered, and each buffer is typically 1 bit or 1 character in length. So, first the signal is received, then the signals are buffered before doing the multiplexing. Then the buffers are scanned sequentially to form a composite data stream. So, we can say that the scanning is done one after the other from different signals from the different buffers to form a composite signal. The scan operation is sufficiently rapid so that each buffer is emptied before more data can arrive. So, here this is being explained, and another requirement is that composite data rate must be at least equal to the sum of the individual data rates. That means, the composite data rate that is being formed here, that one the that bandwidth of this must be, that data rate of this side should be more than the sum of the individual data rates. So, here what is done, some kind of framing, as you can see the interleaving is done, and here we have received coming from source 1 that a part of data from source 1 in time, here it is essentially time. Then the data from source 2, then data from source 3, in this way data from source n. So, these are scanned one after the other, then a frame is sent, then comes the next frame, again it is taken from another source, some 1 bit or more number of bits, then from channel 2 S2 source 2 1 bits or more number of bits, in this way it goes up to channel n, and again it is repeated. This is how it is done, scanning is done. Now, question arises, whenever you do the framing, say you are doing a frame some kind of framing, we are sending, say this is from source 1, this is from source 2, this is from source 3, in this way source n. Then of course, another stream is coming, this is one frame and this is another frame, source 1, source 2, and this is being sent. Now, question arises, how the other side, that is the receiving end, identifies that this is the beginning of a frame, and after the beginning of a frame is identified, then of course, the data from each of these sources can be taken out, provided they operate at the same frequency. So, here the requirement is that transmitter and receiver must operate at the same frequency, and moreover they should be able to identify the beginning of a frame. That is being done by using a separate channel, you can say. This channel is known as sync. Through this channel the sync characters are sent. So, at the beginning of each channel the sync character is sent, synchronization character is sent, and usually the synchronization character is say a sequence of 1 0 1 0. So, you may send 8 bits of 10 1010, that forms the synchronization character, and after this is detected at the receiving end, subsequent slots are for different data. So, this is considered a channel, say channel 1, this is again channel 1. So, in this way channel 1 is repeated. So, for the source S1 data is taken from the channel 1, then data is taken from channel 2, this is your channel 2 from source 2. It is predefined that data will be present in this time slot from source 1, in this time slot from source 2, and so on. Now, sometimes it so happens that the data rate is not matching which is coming from the source. For example, for the purpose of multiplexing, your requirement is say 8000 bits per second. On the other hand, from the source the data is coming at the rate of 7200 bits per second. So, data rates are different. In such a situation, what will you do? In such a case, a technique known as pulse stuffing is used, so that the synchronization of different data rates are possible. So, what is done? Some dummy bits are inserted to generate data rate of 8000 bits per second. Then they are sent by the receiver, and at the receiving end the additional bits which are received are separated out to get back the original data, which has the data rate of 7200 bits per second. So, this is how pulse stuffing is done. Later on we shall take up an example to discuss it. So, here the synchronous time division multiplexing is shown. Here, as you can see, the data is coming from 4 sources. Here you have got A coming from source 1, B from source 2, C from source 3, and D from source 4. Now, as you can see, first frame has filled up all the slots A, B, C and D. That means it is first it is taken from A, then it is taken from B, then it is taken from C and D. So, all the slots of first frame is filled up. However, so far as the second frame is concerned, that A, second B, second C is filled up, but there is no data in the fourth frame. So, this remains empty. So, and so far as the third frame is concerned, as you can see, you have got only 2 data A and B coming from source A and source B, and source C and source D has no data. So, these they remain empty. So, we find that in synchronous time division multiplexing, some of the slots may remain empty if the source has no data to send, as it has happened in this particular example. As you can see, in 4 frames, the first frame is filled up, second frame in the second frame 1 slot has remained empty, in the third frame 2 slots have remained empty, in the fourth slot and the fourth frame 3 slots have remained empty. So, this leads to inefficient utilization of the channel bandwidth or the medium bandwidth. How do you overcome it? This limitation is overcome by using a technique known as statistical time division multiplexing. It is also known as asynchronous time division multiplexing or intelligent time division multiplexing. So, wastage that happens in case of synchronous time division multiplexing, usually we refer to I mean that synchronous time division multiplexing is referred to as TDM.